Page 6 of Applications of Calculus and Kinematics. Number 5. A particle moves along the x-axis with velocity function blah blah blah. Look, instead of writing v, they wrote x, which is the displacement, dash, which is the derivative of displacement, which is velocity. Find the total distance traveled in the time interval 0 to 3 and 1 to 3. Okay, so first thing we need to do is we do need to make a sign diagram for the velocity function so that we can see if their direction changes. The way we do that is we set it equal to 0. So 16t minus 4t cubed equals 0. 16, let's see, t factored out of 16 minus 4t squared equals 0. Oh, we should factor out a 4 also. 4 minus t squared equals 0. Now it's easy to factor. So 4t, we can factor 4 minus t squared using the identity a squared minus b squared equals a plus b times a minus b. So 4 is 2 squared. So this is basically factoring 2 squared minus t squared. It would be 2 minus t times 2 plus t equals 0. What are the solutions here? T equals 0, t equals 2, and t equals negative 2. These are all times when the direction changes. Well, we don't care about the negative time intervals usually. Okay, so there are direction changes at t equals 0 and 2, just to like figure out the directions that the thing is traveling in. Let's look at the velocity sign diagram. We're going to mark 0 and 2 on the velocity sign diagram. Between 0 and 2, that would be like 1. I could plug 1 into my equation here or this equation here, and I could see that that would be a positive number, right? If I put 1, if I put did I say 1? Yeah, if I put 1 in there, I would get 16 minus 4, which would be a positive number. So in between 0 and 2, it's going in the positive direction. Past 2, it's going, let's see if I put a really big number into here. Really big number, positive. Really big number, negative. Really big number, positive. So it would be negative. Okay? So anytime past t equals 2, the thing is going backwards. Okay, so you can see why 0 to 3 would be kind of like a little bit difficult, because you're spanning the positive part and the negative velocity part, which means it's reversing direction in the middle, so we need to separate it out into different pieces. Okay, before we get there, let's just follow the procedure that we were given the previous thing. So we drew the sign diagram to see where the changes of direction are. Then we're going to find s by integration, including finding the constant of integration. And then we're going to find all the s values. So let's find the s function first. The s function we can find by taking the integral of x dash, which is equal to the integral of 16t minus 4t cubed. And that's equal to 16t squared over 2 minus 4t to the fourth over 4. Okay, so, and plus c. So we have a displacement function. It's this one here. I'm just going to simplify it a little bit. I'm going to put 8t squared, and I'm going to put minus t to the fourth plus c. And then I'm going to find out what c is. Well, there is no value for, they don't tell us what the value for c is. Okay, so for now, let's just use as a reference point that it starts at 0. Okay, so let's say that at s of 0, it's 0, just to have a reference point. If I put 0 here and 0 here, you could see that c is going to be equal to 0 because the s function is going to be 0. So that means that c can be considered 0 for now. I don't think it's going to matter. We'll check later, but I don't think it's going to matter. Okay, so the s function is going to be 8t squared minus t to the fourth, period. That's it. Okay. The next thing we're going to do, according to the procedure, is we're going to find the s values at the starting point, the ending point, and any direction change points. So s of 0 is the starting point, the first position is going to be 0, right? If I substitute 0 in for t, 8t squared minus t to the fourth is going to be 0. S of 3, which is our ending point, is going to be 8, 3 squared, which is 9, minus 3 to the fourth, which is 81. Yeah, so 70, let's see, 8 times 9 is 72, minus 81 is equal to negative 9. So the position at S of 3 is negative 9. Last of all, what about at the time when it reverses direction at t equals 2? Let's find out what S of 2 is. It's equal to 8 times 4 minus 16. 32 minus 16 is 16. So the position at S of 2 equals 16. So there's 3 S values we're worried about, 16, negative 9, and 0. Let's map those out on a, what do you call it again? A motion diagram. So we're going to have like an S number line, and we will mark S of 0, S negative 9, S 16, and then we're going to write down how the path goes. First, it's going to start at S of 0, so at t equals 0, the thing starts right in the middle. Then at S of 2, when there's a direction change, it is at 16. And then it turns around. This is t equals 2. And then at S equals 3, it goes all the way to negative 9. At t equals 3. So we can see here that basically it travels 0 to 16, which is 16 units. And then it goes from 16 to negative 9, which is 25 units. So that would be 16 plus 29 would be the total distance traveled between 0 and 3. 16 plus, what did I say again? 16 plus 25. Is that right? 16 plus 25 is 41, right? So 41 is the distance traveled between 0 and 3. What about the distance between 1 and 3? So the distance between 1 and 3, let's see, all we need to do different is now we need to figure out, okay, where is it at S of 1? Because we know the whole path between 0 and 3, t equals 0 and t equals 3. It looks like that. But if we start at t equals 1, it's probably going to be like somewhere here. And we just need to figure out how much less that is, right? So what's S of 1? If I put S of 1, if I put 1 here and here, that would be 16 minus 4. That would be 12. So the position that we're talking about here, and I'm going to make a new sign diagram, or a new motion diagram. And on this new motion diagram, I'm going to have the starting point, which is 0. Oh, it's not the starting point anymore, because now it's going to start at S of 1. Oh, I'm sorry, S of 1 is not, I don't plug it into here. I plug it into the S function. So it's over here. S of 1 is equal to 8t squared, or 8, minus 1, which is 7. Okay, so it would be 7. So my starting point is going to be 7. And then I'm going to go all the way to 16, and then it's going to come all the way to negative 9. So it's going to start at 7, which is S of 1. And then it's going to go all the way to 16, and then it's turn around and go to negative 9, because this is S of 2. And is t equals 2. I'm sorry, I'm writing the wrong thing. I need to write the t value. So I'm going to put t equals 0, it's at 7. T equals, t equals 1, right? T equals 1, it's 7. T equals 2, it's 16. And t equals 3, it's negative 9. T equals 3 is negative 9. So the distance traveled would be 7 to 16, which is 9. And then it's going to go backwards, and that'll be 16 plus 9, which is 25. So it would be 9 plus 25, which is 34. Okay? All right. Now let's look at, is this the last one? No, not the last one. Whoa, that was like such a hard workout, right? I'm already ready to quit. The velocity of the particle traveling in a straight line is given by velocity equals 50 minus, blah, blah, blah. Okay, where t is positive. State the initial velocity of the particle. Okay, so the initial velocity of the particle can be found by putting t equals 0 in there because that's the initial velocity, right? It would be 50 minus 10 and e to the 0, which is 1. So 50 minus 10 is 40. Okay, that's the initial velocity of the particle. Find the velocity of the particle after 3 seconds. Okay, so that would be 50 minus 10 e to the negative 0.5 times 3, which would be 50 minus 10 e to the negative 1.5. Okay. How long will it take for the particle's velocity to increase to 45 meters per second? So in this case, what we're going to do is we're going to say, okay, the velocity is equal to 50 minus 10 e to the negative 0.5 t. I'm going to set that equal to 45. Okay, and then how would I solve that without very much calculator use? First of all, I am going to subtract 45 from both sides. And then I'm going to add 10 e to the negative 0.5 t to both sides. And the reason why I'm going to do that is I want negative e to the negative 0.5 t on one side and everything else on the other side. So that's what I'm going to end up with. 5 equals 10 e to the negative 0.5 t. Divides by both sides by 10. I'll get 0.5 equals e to the negative 0.5 t. If I take the natural log of 0.5, that's equal to, natural log of e, remember, cancels each other out. I'm left with negative 0.5 t on the right side. Because I took the natural log of the left side, it becomes natural log of 0.5. Natural log of e to the negative 0.5, natural log and e cancel each other out. Finally, I'm going to multiply both sides by negative 2. If I multiply both sides by negative 2, this becomes 1. And so this would be negative 2 natural log of 0.5 equals t. And so there is my solution for when does the velocity become 45. Okay, discuss the, what's next? Okay, next, discuss the velocity as, by the way, this part here is c. Discuss the velocity as t approaches infinity. When t approaches infinity, let's look at the velocity equation again. When t becomes infinity, do you see how like the exponent for the e becomes negative infinity, which means super small number? E to the negative infinity is the same thing as 1 over e to the infinity, or 1 over a big number, which means getting close to 0. So we're going to approach v equals 50, right? Because the e part of this becomes 0, multiplied by 10, still 0, and then you're left with 50 by itself. Okay, show that the particle's acceleration is always positive. Okay, the acceleration is always positive because I can look at the velocity equation, which is 50 minus t e to the negative 0.5 t, and I can find the acceleration equation by taking the derivative of the velocity equation. So I'm going to rewrite the velocity equation here just for 1 second. And I'm going to take the derivative of it. Derivative of 50 is 0. Derivative of negative 10 e to the negative 0.5 t is negative 10 e to the negative 0.5 t. And what did you do, Mr. Zwicky? You just wrote the same thing again. Remember, the derivative of e to something is e to something, and then chain rule, negative 0.5. So negative 0.5 times 10 is 5, positive 5. So here is our acceleration expression. Now the acceleration expression, how do we know that the acceleration is always positive? Well, isn't e to the something always positive, right? E to the something has to look like this or like this. It's always above the x-axis. E to the something is positive. So 5 times a positive number, 5 is also a positive number, is always positive. Both this and this are always positive. So the multiplication has to be positive too. Okay, F, draw the graph of v of t against t. Okay, let's draw this graph. I'm going to have t, I'm going to have v, and remember, I know that as the thing approaches t is infinity, it's going to approach 50. Okay. What else do we know? So that was that. When does it reach 45? It reaches 45. Oh, that's like a weird number. Ignore that. Initial velocity of the particle, 40. Okay, so the thing starts at 40, and then exponential function approaches the asymptote. Boop, like that. Okay, draw the graph of v. Okay, so we're done with that. Find the total distance traveled by the particle in the first 3 seconds of motion. Okay, now in this case, we can see from the velocity graph that the velocity is always positive after t equals 0. So we don't need to worry too much about direction changes or anything, right? Because there are no direction changes. It's always, velocity is always positive. So all we need to do is to find the total distance traveled in the first 3 seconds of motion is to take the derivative, the integral from 0 to 3 of the velocity function, and we don't need to worry about that complex procedure because there's no direction changes. What is the velocity function, by the way? So it's just 50 minus 10 e to the negative 0.5t. When we take the integral of this, it'll be 50t minus 10 e to the negative 0.5t divided by negative 0.5. These both become positive, and we're going to substitute 3 and 0 eventually. So if we put 3 here and here, we'll get 150 plus 10 e to the negative 1.5 divided by 0.5 minus 0 when I substitute in there. And then if I substitute 0 in here, it'll be plus 10 e to the 0 divided by 0.5. Okay. By the way, what is 10 divided by 0.5? 10 divided by 0.5 would be 20. 150 plus 20 e to the negative 1.5 minus 0 minus that. So minus 10 divided by 0.5 is 20. E to the 0, which is 1. Almost done. 150 minus 20 is 130 plus 20 e to the negative 1.5. What is this again? It's the displacement in the first 3 seconds. All right? All right. Number 9. A train moves along a straight track with acceleration blah, blah, blah. The initial velocity of the train is 45. Determine the velocity function. Remember, the velocity function is... Oh, in this case, look, they give us acceleration. Now we're going to try and find velocity. Remember, the relationship between acceleration and velocity is this. Derivative of the velocity is acceleration. Integral of acceleration is velocity. So if we want the velocity function from the acceleration function, we need to use the integral. The velocity function is equal to the integral of t over 10 minus 3 dt. The answer is t squared over 20 minus 3t. Okay, and now we just need to find out what c is, because this is plus c, okay? And so the initial velocity of the train, that means at t equals 0, it's 45. So we're going to put t equals 0 and v equals 45. So we're going to get 0 squared over 20 minus 0 plus c equals 45. So it turns out c is 45. So let's rewrite our velocity function one last time. The velocity function is t squared over 20 minus 3t plus 45. There is my velocity function, which is answer to part A. Part B, evaluate the integral from 0 to 60 of v of t and explain what this value represents. Okay, first of all, do we need to be careful about direction changes? Well, we have the velocity function. Does the velocity function have a direction change in our domain? Let's find out by, oh my gosh, this is kind of annoying, right? So why don't we put this, into PolySMLT. So I'm just going to find the A, B, and C values, and then I'm going to plug it into PolySMLT, and then we can find the direction changes, and if there's our direction changes, then we need to, it'll be more challenging. So apps, got to get my PolySMLT. Okay. Oh, PolySMLT. So I'm going to go to PolySMLT. I am going to do polyroot finder, and I'm going to put in my 3 variables, or my 3 values, which is 1 divided by 20, -3, and, -3, and finally 45 for C, and then we'll see what are the solutions. 30. So there is a, let's see, the velocity is 0 at t equals 30. Okay, now look, it says evaluate 0 to 60. 0 to 60 has 30 right in the middle of it, so there is a direction change. Let's do a sign diagram real quick for velocity. So at t equals 30, it's 0. To the right of 30, looks like it's going to be positive. And to the left of 30, it's also going to be positive, because look, there's 2 roots and they're both 30. So basically, what that means is it looks kind of like this, t minus 30 squared, right? So the thing is the vertex of the parabola is right here, and it goes up in both directions, so everything's positive except for at t equals 30. So ironically, even though it looks like there's a direction change, it actually is not a direction change. It just like goes to 0 and then it becomes positive again. So because there's no real direction change, we can just go ahead and say, okay, this is the distance traveled. The distance traveled between 0 to 60. Okay? And it doesn't matter that it looked like there might be a direction change, because there wasn't in the end. All right? 0 to 60 seconds. Done.